Hey guys, I'm here with the Batpack Energy from Hybrid Power Solutions, and this video is really to answer your top 10 tech questions, not only in regards to this product itself, but also solar generators and power packs in general. So here we've got the Batpack Energy. This is the extended range model, so it's a 3.6 kilowatt hour, so 3,600 watt hours of battery of energy storage and 4,000 watt continuous of output. So here we've also got the model that has your solar charging capability, and we'll use this as our little demo here for today and answer your questions. So let's dive right in. So question number one is, why did we go with LiFePO? Why did we choose LiFePO for this product? And that came down to two big points. One, safety. LiFePO is actually one of the safest chemistries available in mass production right now. And in the conditions that these are operating, such as mining, underground, households, we want to make sure that we did have the safest chemistry available. Reason number two is cycle life. LiFePOs have a lot longer cycle life than than other NMC chemistries or other lithium-based chemistries, and a lot longer than any kind of lead-acid-based chemistries. With these being used on the daily, if you drive an electric car, you're maybe putting 1 or 2 cycles on a week. With this, if you're using it every day, you might be putting 1 cycle on daily. And so we wanted something that was going to really last a lot longer than anything else that's out on the market. These are rated for 2,500 on the base model cycles, and on this extended range, they're 3,000 cycles. Now that being said, that's 100% depletion. So if you are just doing, say you're only taking it down to 60 to 70% or of its complete charge, then you'd be looking at a lot longer lifespan. And that's why we went with LiFePO. Second question, Coulomb counting. Hopefully I'm saying that right. But basically Coulomb counting is a way of precisely and accurately counting how much energy you actually have left and stored in your unit. A lot of cheaper models, especially the ones that use NMC or a cheaper chemistry, may actually just calculate the voltage of the battery itself and then basically do an estimate on how much energy is left. It's great with lead acid because it's a nice and linear scale, but on other lithium chemistries, it's really not an accurate way of gauging how much energy you have left in your system. So as I just mentioned in question 2, question 3 sort of relates to the same thing, and it's based on the fact that we have a really intelligent and fully integrated battery management system. The question is, how does low and high temperature affect the product? But not only that, but is it actually tracking this? So a lot of cheaper products won't really care. Either they'll have very limited thermal management, or they'll just care if the product is too hot. Our system actually detects if it's too cold and won't let you charge in conditions which would actually damage the batteries. So that's key there. And that's why we've actually developed a cold weather package for these units. So you can order these with a cold weather package, and that'll allow you to charge in basically any conditions. So it'll actually warm up the battery first, then start a safe and gradual charging of the battery. It'll also monitor the overheating conditions. So that means that if there was any kind of sensor that picked up a weird anomaly or a very high temperature, the whole system would either shut itself off or actually lower the amount of available power to you.
Question number 4 is with regards to safety. So what are the safety recommendations that we would make for any kind of solar charging kit or any kind of solar power pack or whatever you want to call it? And then there's a lot of levels, and you want to level it up as much as you can. So in our unit, the first thing is going to be, the first line of defense is going to be our BMS and your inverter system, which are going to automatically detect any kind of issues, overpower, overcurrent, all that kind of stuff, and then adjust from there. Either just shut off or some internal fuses will pop. These are all CSA or CULUS rated fuses, which is obviously important. Then we've got our master cutoff switch, so if there was anything that was happening outside the unit itself, so some kind of danger that the user or operator actually started, we've got a kill switch here, it's a master switch. Our new units actually have the same thing. They're just all built into one switch, and you can hit that and it'll turn off the power. It'll actually cut the power to the battery itself, which makes it a lot safer. On top of that, we've got a contactor or shutoff that'll try to shut off the power as well. And we also have internal fusing in the module. So this is our extended range module. So that's actually what's inside here. And it has one of these little guys. So this is actually a 300 amp rated fuse. These are our CSA rated, and they are rated for up to 32 volts AC, and this is a 24 volt battery. So that's appropriate for that, and that's an internal fuse, and that's kind of your last line of defense until you get to the main cells, which are inside, and those have overcurrent protection in the way of a vent cap which blows on each one of them if something were to happen to the cells. Hey guys, so I brought it back into the shop for question number 5. So that's with regards to pure sine wave and modified sine wave. So a lot of cheaper units will use a modified sine wave, which is all right for a lot of equipment, but can damage other equipment. So here we just wanted to show you that our units are actually pure sine wave. So what we've got here is an oscilloscope, and so I've got it wired, measured here, just a little dongle, and we'll just place that so you can see it. Hopefully we can get this all in one shot. But I'm just going to place this right on the hot plug here. Hopefully I've got it. There we go. So you can see here that's a nice sinusoidal wave. And that's really what you want, which is the same as what you get right out of your wall.
Question 6 is this actually 4,000 watts? So a lot of other products out there, they, especially on the cheaper end of things, they may say 1,500 watts or 1,000 watts or 500, whatever it may be, output, and you plug into it and you get that for about 5 minutes, and then it overheats or it just starts limiting power. So that is not the case with this. In normal operating conditions, this will allow you to take the full 4,000 watts continuously from 100% down to 0% battery. You obviously, if you're working in really extreme temperatures, 45 degrees Celsius or 110 degrees Fahrenheit, there may be overheat protection that engages or limits your power at a certain point. But under normal operating conditions, this will allow you to pull the full 4,000 watts, 2,000 out of both if you like, and yeah, for the full duration of the batteries.
For those who are a little curious about the 4,000 watt continuous, want a little proof, what we got here is we've got ourselves set up to do 3 of these 1,500 watt heaters. So we've got them all plugged into here. Obviously don't recommend this unless you know what you're doing. These are 12 gauge cables, so they will handle it for this temporary test. Always make sure that all your wiring and cabling and any kind of extension cords or splitters are all rated for the amount of power that you're actually inputting through the final cable. So right here. Anyways, aside from that, we've also got our volt here. So we're running at about 120 volts, 121.5 there, which is well within North American standards. We've got our one fan working here. That's on full blast. And just to show you guys, these are 1,500 watts. So there it is, 1,500 watts. And we've got 3 of them. So this one's not on, so we've got the first one on over here. I'm gonna crank this one up. You'll see a voltage dip here, set voltage at 118. So it cranks up. So got that one, and then this will actually, we'll just put it on the second level, which is probably going to be around the 1,000 watt, I mean maybe 500, 800 watts. So we'll see how that looks. We got all 3 there. So here you're pretty much approaching the limit, and you're about 115, which is still within the safety threshold for North America. And let's just for fun, let's see if we can put it up full blast. Yeah, so we do see a slight voltage dip on that, but still 112, which is well within the safety limit and what you'd be looking for, and you got all 3 units running. So for the sake of this video, I won't make you guys watch until it's fully depleted, but you could do at least the 4,000 watts and maybe cranking this down on a continuous basis.
7th question on the docket is solar charging, MPPT, PWN. I'm sure you've heard a little bit of each. Which one's better? MPPT is obviously the better, the better technology, and that's something that we've actually just transitioned to. So all our units that are now shipping have MPPT built into it. These accept 24 volt rated panels, and up to 800 watts of panels can be plugged into the unit via these MC4 connectors right here. So we do sell our own panels, and down here you'll see it's our folding solar panels. They're 250 watt, but you can go ahead and basically pick up any kind of solar panels that have MC4 connectors and that are rated for 24 volts, which means that you can do parallel setups. You can do series with 212 volts if you wanted to. But really, sky's the limit on what you get and where you get them from. We're not here to limit what you want to plug into these units. So question number 8 is with regards to how can I expand this? All right, so you've got a 2.5 kilowatt hour on our base model, and this one here is a 3.6 kilowatt hour version, which are extended range. But say you wanted to add I don't know, an extra 2, 3, 4 kilowatt hours of energy. How do you do that? So what we've designed and developed, and we're just about to launch, is our multi-purpose input. So basically it'll accept anything from a 12 to a 30 volt DC input. And so you can plug in anything from deep cycles to lead acids to whatever kind of battery you do want. And obviously you got to make sure to protect those batteries that you are plugging in so they don't over discharge. But this will take that and charge up the internal battery itself. The cool thing too is that you can actually do alternator charging, so you can actually wire it up if you know how, and we have tutorials on this, and to your alternator or to your battery vehicle, or your vehicle battery, excuse me. So that'll allow you to charge while you're on the go. Say you're going to a job site, or you're going out in your RV or on a boat or whatever it may be, and you've got the engine running. You can actually recharge at the same time as you're driving along. So it's a pretty cool feature. It also allows you to do anything, any other DC input that you may have that is controlled. So you could add an external solar panel and solar controller. You could also do a wind turbine if you wanted to with a controller. Just make sure that it's within those voltage ratings and that it's no more than 30 amps.
So for question number 9, we brought it back into the shop just so we get a better look at this, an up close and personal look with the unit. And the question is, why don't we have on our product any kind of USBs or 12 volt outputs? And so you'll see in the front here, basically you've got your 120 volt outputs, T-style plugs, 20 amps each, and your input was just an extension cord here. And you flip that around, so there's no fancy charger, adapters or anything like that, or external chargers. It's all built into the system, so it's easy to use. And the reason why we didn't go with a USB or 12 volt output, it's honestly just something else that could fail. It's also something that's really, really cheap. So it's a lot more expensive to actually build these into the units than it is for people to go out there and get their own little adapters, from $5 to $25, and just plug them right in. You can get some really good 12 volt regulated outputs from 120 on to 12 volts, as well as some USB, chargers for phones or laptops or whatever it may be. So we thought, to keep it simple, keep it foolproof, keep it reliable, we'll just omit that, and people can go out and get their own.
Last but not least is question number 10. So question number 10 is, why isn't there a screen? So you'll see here in the front that we've got a nice display. We've got, it's just your state of charge, that's all it is. Why don't we have some kind of LCD, LED, whatever it may be, screen on there? And it really came down to the fact that, we built a product based on reliability, and, the features are there, but they're buried. They're not, you're going to be plugging things in, you're going to be using your equipment, you're not going to be playing around with this like a toy. And so that's why we went with a really simple, easy to see gauge. You can see this from far away, you can see it at night, and it's all analog, and in half a second you can tell exactly how much energy is left there. Now, for those who do want the full tech features, what we are doing is we're actually developing a browser-based system, so a Wi-Fi and LTE, where you can actually log in from your phone, your computer, your iPad, whatever it may be, and see a detailed list of all the information. So that could be anything from how many cycles you put on, is it charging, is it discharging, at what rate, and that'll also include location, so where is it located. This is obviously really important if you have a lot of different units out with a few different crews, if you're doing, if you're using this as a contractor or a bigger operation. But it's also great if you're at home and you've got this unit powering something that's really important far away, or your cottage or your cabin, and you want to know, is it charging at the right rate? Is it discharging? Is there a problem going on? Is it powering something else? And you can do that from basically anywhere in the world, which is a really cool feature. And that'll be Wi-Fi connected, but as mentioned, it'll also be LTE. So anywhere you have cellular data, you'll be actually able to pick up that signal and monitor your system as well.